everybody and welcome back to another video. In this video I will be covering the most fundamental concept that you will learn from mathematics that you can apply to physics and engineering. It is quintessential that you really do understand this concept. So what this is that when you have a function of x, that you can rewrite it as a sum of terms in a polynomial. So you could write it as an nth degree polynomial. So this is our function right here, and in this video we will be using a is equal to 0. So this says that f of x is equal to the sum from n equals 0 to infinity of f to the n of 0, or the nth derivative, not raised to the nth power. This is saying the nth derivative of our function at 0 divided by n factorial times our x to the nth power. So this would say that our function is equal to a constant plus a second constant times x plus a third constant times x squared divided by 2, or you could just write this as a third constant and have the divided by 2 in there, plus a fourth constant times x to the third, and you get it. It just goes on and on and on forever. So let's see where we get this idea from. So to begin, let's graph out the function sine of x. So I'll draw our axes here, and let's go like this. So sine of x looks something like that. So we don't need to know it too well. So this is -1, this is 1, and this right here is 0. So to begin, let's just see what our function is equal to at point 0. So at 0, our function is 0. So in order to have our function at the right location, we are just going to start off by having 0 as our first term. Now, let's look at the derivative of our function. So f of x is equal to sine of x. So the f prime of x at point 0 is equal to the negative, or just the cosine, sorry about that, of 0. So the cosine of 0 is equal to 1. So we want our derivative of our function to equal 1 at this point. So we have df of x divided by dx is equal to 1. So when you integrate this, you get that f of x is equal to 1x. So we are going to add x right here. Now let's account for our second derivative. So we want the second derivative to be equal to, so the second derivative of f of x, which is just going to be equal to 0 in this case. So our function, because that is the negative sign of 0, which is just 0. So there's going to be no term with x squared, as this would multiply into it. So we don't have to integrate this one, but let's look at the third term. So our third derivative of sine of x with respect to x is equal to, so let's just write this as f of x, is equal to the third derivative of sine of x, which is just the negative cosine of 0, which is just -1. So this is -1. So when we multiply both sides by the new denominator, we get this. And when you triple integrate this, you get that this is equal to, we are not going to have any constants here, this is equal to -x cubed. Then in order to get each one of these, we had, first off, our first integral made this into -x, then we had 2 integrals after this. So then this became -x squared divided by 2. So then these go away. So then we have the integral of -x squared over 2 with respect to x. And when you integrate this, you just get -x cubed divided by 6. So this would be over 6. So now we are going to add a -x cubed divided by 6, and we are going to keep on doing that with every single derivative like every single additional derivative of our answer to make sure that it more and more and more and more approximates this function at a further and further away distance. So our approximation is that sine of x approximately equals x minus x cubed divided by 6. So we know that x is approximately equal to that. And now if we were to use a Taylor series, let's look at what that would give us. So we are looking for our third value of our Taylor series. So our first value, it's the first derivative divided by, it's the 0th derivative. So just the f of x divided by 0 factorial, which is just 1. And we were using at 0, so these are all 0. So that is just the derivative of sine, which is just 0. Then that is plus our first derivative of sine, which is 1, divided by 1 factorial, which is 1 times x. So that would be plus x. Then we would get plus our third derivative, or our second derivative, which is negative sine of x, which is 0 at this point. So that would just be 0 divided by our second factorial, which is just 2 times x. So this term would cancel out, and then we would get plus our third derivative, which is negative cosine x at 0, which is equal to negative 1. So plus, this would be negative 1 times x to the third, since we're on our third term, divided by 3 factorial, and 3 factorial, that is equal to 1 times 2 times 3, which is equal to 6. So through our series, we get x minus x cubed divided by 6 is our approximate value of sine of x. So what we are doing with this formula is essentially just taking a bunch of derivatives and dividing them by values such that when you integrate your function, you get that as your nth derivative. So the n factorial cancels out the power rule. As let's say you had a 4th degree polynomial, or a fourth derivative. In order to get there, you would have to go from your first, or from your 0th power, so this would just be a constant, so constant. Then you would have to go constant times your value x when you integrate it once. Then you would have to go to your constant times your x squared divided by 2 due to your power rule. Then you would have to go to your constant divided by, or your constant times x cubed divided by 2 times 3. And let's not forget there's 0 factorial here, which is 1. And then there's 1 times 2 over here. Then there's 1 times 2 times 3. And now for your fourth, this is just going to be cx to the fourth divided by 1 times 2 times 3 times 4. So I hope that this makes a lot of sense to you now, as you are just rewriting this function so that way its nth derivative will be there when you take that many derivatives of it at the value 0. So I hope you all learned a lot from this video and really understand this topic. Now, I really enjoy this as I find it to be like the pinnacle of mathematics. How did somebody think of this? How was somebody so brilliant that they were able to derive this formula right here, which changed all of mathematics and physics as a whole? And thanks for watching.